This is a video tutorial on how to complete comparative relational thinking problems when they are multiple choice problems. So we're going to learn how to eliminate the wrong answers and find the right answers to be able to explain the reasoning. So this problem says 10 times 6 equals 5 times 12. We're not going to worry about all of these words yet. We're just going to solve the problem first. So 10, I want to see what I could compare it to get the answer of 5. So I know that 10 is 2 times larger than 5, so I have to divide 10 by 2 to give me 5. If I divide this one by 2, then I have to multiply 6 times 2, because when I'm doing multiplication, I do the opposite operations. So this one's divided by 2, this one's multiplied by 2, similar to addition. Then I do 6 times 2 will give me 12. I know that these equations are balanced because 5 times 12 is equal to 5 times 12. So now I'm going to look at the words. Without multiplying the numbers on each side of the equation, which reasoning could explain why the equation must be true? The equation must be true because, so now we're going to go through our multiple choice answers. A, you can multiply both numbers on the left side by the same amount to equal the right side. So did I multiply both numbers by the same number? No, I multiplied one and I divided one. So I do not multiply both of them. B, you can divide by 2 on the left side to equal the right side. I divided one and I multiplied by 1. So I didn't divide both of them by 2. Next, you could divide by 2 and multiply by 2 on the left side to equal the right side. I divided by 2 and then I multiplied by 2 and I got the same as the right side. So I think C is correct. Let's look at D just to check. D says you can subtract 5 and add 5 on the left side to equal the right side. Well, I know that is completely wrong because I'm not doing subtraction when we are talking about multiplication. When I talk about multiplication, we're either doing multiplication or division. Next one says 4 times 9 equals 12 times n. So let's use what we know about comparative relational thinking to make these two sides balanced. So I'm trying to make the 4 equivalent to the 12. In order to do so, I have to multiply 4 times 3. I know I have to do the opposite equation or operation now, so I have to do 9 divided by 3, which will give me 3. So I believe that n equals 3 because 9 divided by 3 equals 3. So I'm going to try to find a reasoning over here that talks about 9 being divided by 3 and n equaling 3. So let's read the question. Without multiplying the numbers on each side of the equation, which reasoning could you use to figure out the unknown number that makes the equation true? So let's go through all of them as we did in the last one. One factor should be multiplied by 3 and the other divided by 3. Okay, one is multiplied by 3, the other one is divided by 3. That's right. This one says the unknown must be 4 divided by 3. Nope, I didn't do 4 divided by 3, so that one is incorrect. Both factors on the left side should be multiplied by 3. The unknown number must be 9 times 3. Nope, both factors were not multiplied by 3. One was multiplied and one was divided, and we definitely didn't do 9 times 3 to get 3. The next one, C, says both factors on the left side should be increased by 3. The unknown number must be 9 plus 3. Definitely not. I'm not doing addition or subtraction when we're talking about multiplication problems. We're only thinking about multiplication and division. Lastly, let's look at D. Hopefully this is the right answer. One factor on the left side should be multiplied by 3, and the other should be divided by 3. The unknown number must be 9 divided by 3. Yay! I did 1 that I multiplied, 1 that I divided, and I got 9 divided by 3 for n to equal 3. So D is the correct answers. Even though these may seem a little bit intimidating with all of the words that you may not be used to in math, if you use this strategy and go through each one very slowly and check it over, you will be able to find the right answers for any of these.